Hi, this is Mrs. Marito. Welcome to section 1.6 for Algebra 1, Compound Inequalities. So for example 1, understand compound inequalities. This question is asking us to try to write a compound inequality for the graph. So instead of being given an inequality and asked to solve and then graph, this one's giving us a graph and then we're trying to write the answer. The reason this is called a compound inequality is because there's two different pieces we're trying to combine. You've got two different dots here. And so this first one by the -2 is open and our shading is in between. So if we just look at this -2, we could write x is greater than -2. And then for the 6, if we ignored the -2, if we just wanted to write an inequality for the 6 with the closed dot, we'd say x is less than or equal to 6. So we've got the two pieces, but we want to combine this. That's that compound inequality idea. And so we're going to write x in the middle, and then we can copy this 6 part. So x is less than or equal to 6. And hang in there with me. We're going to flip this around a little bit. Now I'm going to say x is greater than, I know that sounds kind of backwards though, -2. So if we look at these two pieces, this, if we read this way, x is greater than -2. That's what we want. X is greater than -2. And then if we read this way, we get our x is less than or equal to 6. That's what we want. So let's write this up in words though. Oh, do you hear my dog? So in words, we can say x is less than or equal to 6. That's the less than or equal to 6. And needs to be both. X is greater than -2. So we say this is an example of an and inequality. Now, I'm boxing it to emphasize that's not the answer. So we're emphasizing this is an and, there's two pieces to it. So your final answer is all of this up here. X is greater than -2 and less than or equal to 6. Let's do one more example because not all of these are ands. So I called this new one example B. So I'll go back. Let's call this example A. So take a second and draw example B. It's just a number line, same numbers, -2. We always like to put the 0 and then the 6 with the open dot over the 2 and a closed dot over the 6. The difference on this one is the direction that your arrows are going. So for the first piece, we'll say now x is less than -2 because it's going to numbers below -2, or x is greater than or equal to 6. And so in words, we can say x is less than -2, I should emphasize, or x is greater than or equal to 6. So this is an example of an or statement for our compound inequalities. One last little side note before we move on. Off to the side, just a little quick note. If you have an inequality and, Pebbles, shush, I'm working. And you've got your dots and the shading is going in between. So let me make that a little better. So you've got your dots, open or closed, and the shading's going in between. We say this is an and statement, and a quick way to remember, A, N, D, like there's three little pieces. And then for the or, you'd have a dot here and a dot here, and of course they could be open or closed, but your ors always go out. Your ors go out. And so this would be an OR, like there's two pieces. So nothing mathematical over here. That's just a nice little quick check. So now we're going to do two more examples. Example 2 is asking us to solve the compound inequality for an OR statement, and they can't hide an OR for you. It's going to say OR. So we'll set this up. Negative 3x plus 2 is greater than negative 7, or 2 times the quantity x minus 2 is greater than or equal to 6. So we're going to solve these separately, just like you solved your equalities. So we're going to subtract 2 from both sides. Those will cancel. We get negative 3x is greater than negative 9. And then isolating our variable, we'll divide both sides by negative 3. Oh, be careful. We're dividing by a negative. That tells us we need to flip the inequality. Negative over negative, we get our positive with that division. So negative 9 divided by negative 3, positive 3. And then we just 2 for 1. We got to do the next guy. So we're going to distribute our 2. We get 2x minus 4 is greater than or equal to 6. And isolate your variable, so we'll add 4 to both sides. 2x is greater than or equal to 10. Divide by 2. And x is greater than or equal to 5. So the last part is to write this up as a solution and then graph. So our final solution, when we write this all together, we've got x is less than 3, or x is greater than or equal to 5. There isn't like a smooth way to combine these. If it's an OR, you just have to write the OR. The last part though is our graph. So always, let's see, we'll put our 0, 1, 2, 3, 4, 5, 6, 7, there's a little room, I'll put negative 1. All right, and so when we graph x is less than 3, we have an open dot at 3, and then we're going to draw and shade our arrow to the left, the less than, and then for our x is greater than or equal to 5, we have a closed dot at 5, and then we're going greater than, numbers that are greater than positive 5. So there you go, that's your answer and your graph. We're going to do one more. Let's try one with an and. All right, so this is our last example. We're going to do one with an and. So we have negative 2 times the quantity x plus 1, that's your parentheses, is less than 4. And, that's what they give us right there, and 4x plus 1 is less than or equal to negative 3. So we'll tackle these one at a time. Distribute, always first. We get negative 2x minus 2 is less than 4. And we'll isolate our variable by adding 2 to both sides. And we get negative 2x is less than 6. Divide by negative 2. Hey, dividing by negative. Don't forget, we have to flip that sign. So we get x is greater than negative 3. And again, it's a 2 for 1, so we got to do the other one. We'll subtract 1 to get our x. Oh, I think my dog's going to bark. Time out. Bubbles. It's all good. You okay? Okay. So we're going to subtract 1 from both sides, and we get 4x is less than or equal to negative 4. Then we'll divide by 4. Our 4's cancel. And I don't want to mess with your brain too much. There's a negative up here, but we're not dividing by a negative. So this isn't one of those flip the inequality ones. This is just x is less than or equal to negative 4 divided by 4, negative 1. So our final solution, and I'm going to show you two ways you can write this. You could write x is greater than negative 3 and x is less than or equal to negative 1, but we don't write it that much very often. It's true, that's not a wrong answer, but if you're working online with any math curriculum or in Math Excel or Delta Math, or on multiple choice problems, the way whenever you have an and, the way you're going to write this is to put the x in the middle, kind of like we did, which one was that? On example 1a. And then we can copy the less than part, x is less than or equal to negative 1, and then we rearrange this first one, we flip in the negative 3. So this reads x in the middle, so x is this part greater than negative 3, and then this way, x is less than or equal to negative 1. So this is our favorite answer in algebra. We want to write our ands like that. The last part is your graph. So we've got lots of negative action. Let's see, -3, -2, -1, 0, 1, 2. And so for our graph, we're going to have at -3 an open dot. And we're going to shade this way, but I'm not going to finish yet because an and is going to go in the middle. So my other side is x is less than or equal to -1. So that'll be a closed dot, and that tells you where to stop. So then we just shade that area between, and that's your final graph. And that's it for section 1.6. Just some reminders. Make sure you go back and copy down all of your notes if you missed anything, and bring all of your questions to class. Thanks.